Hey everyone, we're looking at 4.7 day 2, and we're continuing to talk about inverse trig functions. Yesterday, the previous day of notes, day 1, that was mainly focused on the unit circle and using the calculator in radian mode. Here now, we're talking more about story problems or word problems. We'll be diagramming those with right triangles, and then we'll actually be in degree mode. So again, just a reminder to set the mode of your calculator depending on what the question is asking for. So we'll get to that in just a moment. As we're talking about these word problems, oftentimes they give us these vocab words to describe the kind of angle that we're dealing with, either angle of elevation or angle of depression. So let's draw a little diagram and represent what we have here. Anytime they're talking about angle of elevation or angle of depression, you always have to have a horizontal line that forms a side of that angle. So if this is my horizontal reference line, and we're going to put a triangle on top of that. So notice, there's my right triangle, that the side of the triangle that's on the base is also my horizontal reference line. So then looking upwards, there's my angle of elevation. So it's a combination of the base and the hypotenuse that forms that angle of elevation. Now, with the angle of depression, again, I'm going to draw the triangle this way instead. If we take a look at our right triangle here, you might say, hey, that must be the angle of depression, and it's not, because you always have to have a horizontal forming the side of that angle, whether it's angle of elevation or angle of depression. So we need a reference line up here. I'm drawing a dashed line because it's not actually a side of the triangle itself. There's your horizontal reference line. And then from there you drop downwards. That's your angle of depression. So notice the angle of depression is this horizontal reference line and the hypotenuse. So in both cases, the hypotenuse is always used. But that angle is outside the triangle. We don't want that one. We need the angle inside the triangle because that's the figure we're actually working with. So how do we find that angle? So if this is a horizontal reference line and this is a vertical side of the triangle, then that means these are perpendicular, and that means we have a right angle here as well. So this will be a complementary pair. So, for example, if they tell us that we have a 20-degree angle of depression, well then this must be 70. And now we can work with the 70-degree angle as a reference angle, not the 20, because we want the angle inside the triangle. But let's think a little bit further about this. Back in geometry, you learned that if you have parallel lines intersected by a transversal, that these are opposite, alternate interior angles, and they will be congruent. So if this is 20, then this is also 20, and that makes sense because all three angles will add up to 180 degrees. So when we're trying to find an angle inside the triangle and you're given an angle of depression, you can either use this pair of alternate interior angles because they'll be congruent, or you can use this pair, and that will be a pair of complementary angles. So let's take a look at example 1 here. Before we get to the story problems themselves, we're just pointing out or just reminding you from day 1 that we can use the calculator to find the angle, and we're going to do that by finding the inverse of that trig function. So here in this example, we have cosine of some mystery angle, and that cosine again is the ratio of two sides on your triangle. That's your adjacent over your hypotenuse ratio in decimal form. We're going to use that ratio and go backwards to figure out the size of that angle in that triangle. They want us to find that value of theta, that angle, in degrees and in radians, and this is just telling us that we're in quadrant 1 only. So as my calculator is already set up in radian mode, I'll get that answer first. So what we're doing here is, and we learned this yesterday, to isolate the variable you have to take the inverse cosine. So there's the symbol. It looks like an exponent. It's not an exponent. It's just a superscript that communicates to us it's the inverse cosine, or cosine inverse. And that's what we'll type into our calculator. So inverse cosine of that 0.3746. So that's my answer in radians, 1.186, and I'll round to 2 decimal places in the word problem, so I'll do that here as well. So 1.19. We usually don't assign a label, but it is in radians, and I'll go ahead and add that in just to clarify, because we're also finding this in degrees. Now we have learned how to convert radians into degrees with a multiplier, but we'll just use our calculator instead and just change the mode. So back to the mode screen and setting up degrees instead. Once again, inverse cosine of that 0.3746. So there it is, 68 degrees. You can see it's rounding to 0.00. And the rest of the problems are we'll be working with degrees here, so I'll just leave the calculator in degree mode. So let's look at a few of these instances here. We're trying to represent each situation with a right triangle, and we have to pay close attention to where the given information goes and which angle they want us to find as well. Now with each of these, we are going to try and find a ratio of two sides on our triangle. Here they just assigned us the cosine ratio in the previous example, but we have to figure out our own ratio. So remember that SOHCAHTOA as a way to organize your information, organize the pairing of each ratio so that we know whether to use sine, cosine, or tangent. So here's the example number 2. We have a 40-foot ladder that leans against a building. If the base of the ladder is 6 feet from the base of the building, then what is the angle formed by the ladder and the building? All right, so here's my ground, and here's my building. So we'll say that's the wall of the building. And here's my ladder, and they tell us that it is a 40-foot ladder. And they tell us that the base of the ladder, so that's down here, that's the bottom of the ladder, is 6 feet from the base of the building. So here's the base of the building, here's the base of the ladder, so that's describing this horizontal segment. That's your 6 feet. Now we're assuming we have a building that is standing straight up, so that'll be forming our right angle with the ground. And now we have to figure out what angle they are asking for. What is the angle formed by the ladder and the building? Okay, so the ladder is on my hypotenuse and the building is on the vertical side, so I'll put theta here in that top angle. That's what we're trying to find. So that's our reference angle. So if that's the reference angle, we have to label the side. So this is the adjacent side of my triangle, this is the opposite side of my triangle, and there's the hypotenuse, right? That's always opposite the right angle. So we are using the 6 feet and the 40 feet to create our ratio. That's the combination of opposite and hypotenuse. So that means we're using the sine function. So sine of my reference angle equals, that ratio is opposite over hypotenuse, so 6 over 40. That's our setup. Let's get theta by itself. That means we're taking the inverse sine of both sides. And we'll type this into our calculator. Inverse sine of that 6 divided by 40. So we get 8.63. Again, I'm rounding to the hundredths. And that'll be in degrees. So that's the angle at the top there. Here's example number 3. Let's find the angle of depression from the top of a lighthouse 250 feet above the water to the waterline of a ship 2.5 miles offshore. Notice the units are different here. We have a lighthouse that is measured its height in feet, but we have a ship out from the shore measured in miles. So we want to convert both of them to the same unit. Let's convert everything to feet. So I'm going to start off by converting that 2.5 miles to feet. So here's my multiplier, 2.5 miles, set that up over 1, and we want to match the units first. So we want miles to disappear, so we're going to put miles in the denominator on a multiplier. We want feet instead, so that goes on the top. And in a single mile, there are 5,280 feet. So you can see now when you multiply these fractions, the miles will cancel off, and we'll just have feet remaining. So a little calculator work here to get that pretty big number. We get 13,200, and that's in feet. So that's how far the boat is from the shore. So here's my water line. There's the water. There's my boat. And here's the shore. And there's the lighthouse. So we're just kind of assuming that the lighthouse is standing right at the base of the water. So we get that representation of a triangle. So we know that the lighthouse, the top of the lighthouse is 250 feet. And we know then that the distance to the ship is that 2.5 miles, which is that 13,200. So that's what we know. Now they're asking us to find the angle of depression. Remember, that is your angle formed by this horizontal reference line looking down. That's your angle of depression. But again, we've learned that these are parallel. And this is your transversal, which means that this angle of depression is in fact the same as this angle of elevation over here. So this is the angle we want to find, and it will be the same size as the angle of depression. So this is the angle we want to find. This was our reference angle. Let's label a side. So this 13,200 is my adjacent side of the triangle. The 250 is my opposite side. And there's my hypotenuse. So again, we want to use the 250 and the 13,200 because we have to create a ratio of two sides with two numbers. So that's opposite and adjacent. So that's going to be our tangent ratio. Tangent of my reference angle theta is opposite over adjacent. So 250 over the 13,200. That's a pretty big denominator, so we would expect a pretty small angle here. Inverse tangent of that fraction, and that's what we'll type into our calculator. Again, this is in degree mode. We haven't changed that, so it's 1.085. I took a look at that earlier, and if we were, of course, rounding to two decimal places, we'd round that up to 1.09, and that's in degrees. That's this angle of elevation, which is also the same as that angle of depression. So we have answered the question, and we're good there. All right, let's finish it off with example 4. An engineer erects a 75-foot vertical cell phone tower. Find the angle of elevation to the top of the tower from a point on level ground 95 feet from its base. So here's the ground. Somewhere there's a tower. We know that it's a 75-foot tower. And we want to create a triangle out of this. So we're measuring on the ground. We have this point on level ground that is 95 feet from the base. So it's like I'm going to walk 95 feet away. There I am, 95 feet from the base of the tower, and I'm going to look upward. And as I'm looking upward, that's my angle of elevation. That's the angle we're trying to find here. So once again, we have a right triangle. So that's my reference angle. This is the hypotenuse. The 95 is on the adjacent side. The 75 is on the opposite side. And again, we want to create a ratio of two sides. So we're using the two sides with numbers. That's the opposite and the adjacent. So one more time, it's tangent. Tangent of the reference angle is opposite over adjacent. So 75 over 95. Let's take the inverse tangent of both sides. So inverse tangent of that fraction. And again, this will be in degrees. So I typed that in earlier, and I came up with an answer of 38.29. So type that in as well. Make sure that you can get that also.